So now let's take a look at something that is called Pascal's identity. And it's called Pascal's identity kind of because it relates to Pascal's triangle, and they just sort of name everything associated with this triangle after Pascal. This identity appears on your formula sheet, I believe. So you do not need to memorize it. What you need to be able to do is be able to use it to do things like these questions that I've written down here. And it's also good to kind of understand what it means a little bit. So here's a typical question. Write the equivalent combination to each of the following. And they give us 5 choose 1 plus 5 choose 2. If we go up and we look at Pascal's identity, we've got a value for n, we've got a value for r. So it relates n and r to another combination involving n and r plus 1. And these things are equal to another number, n plus 1, and another number, r plus 1. So when you're approaching these questions, you want to think about what number should I put in for n and what number should I put in for r. So if I look up at the first number in these two combinations, I notice that it's the same. I got a 5 and a 5. If I look at Pascal's identity, the place where I have two numbers that are the same as the first number in my combination are on the left-hand side of the identity. So that's telling me right away that in this question, n is equal to 5. If I look at the next two numbers down at the lower part of my combination, I've got a 1 and a 2. And if I look at the left-hand side of Pascal's identity, those lower numbers, one is r and one is r plus 1. So one should be larger than the other by 1. So if I've got r and r plus 1, this is my value of r down here. R plus 1 is 2. So r equals 1. I'll just say r plus 1 is equal to 2. So what is this whole thing equal to? Well, this is the left-hand side of the identity. The right-hand side is n plus 1, r plus 1. So n plus 1 choose r plus 1. So we need a combination over here. And what goes up at the top? Our first number is going to be n plus 1. If n is 5, we put a 6 in there. And we want r plus 1 down at the bottom, 2. So 6 choose 2. If we see something like this, where we are subtracting, we look at Pascal's identity and we don't see subtraction anywhere. But we can rearrange Pascal's identity a little bit if we want to get subtraction. We could say that n choose r is equal to n plus 1 choose r plus 1 minus n choose r plus 1. Now if we look at these top two numbers here, 12 and 11, we see that one of them is n plus 1. The other one is n. So n is 11 in this question. If we look down at the bottom, this 4 here and here has to be r plus 1. So 4 is r plus 1. R has to be 3. So what is this equal to? Well, it's equal to the other side of Pascal's identity, n choose r. So 11 choose 3. Now, what does any of this have to do with Pascal's triangle? Let's look at this first example. 5 choose 1, 5 choose 2. What is let's treat our n value, okay, as the row in Pascal's triangle. Okay? So if n equals 5 is a row, and let's treat our r value as sort of the term in each row. Okay? So if n is 5 and r is 1, we are looking at the first term in the fifth row, which is a 1. Okay? If we're looking at, if it's 5 choose 2, we are looking at the second term in the fifth row, which would be a 5 over here. Okay? Our third combination over on the other side of Pascal's triangle is the sixth row, second element. So the first row in the fifth element plus the second element, also in the fifth row, should equal the second element in the sixth row. In other words, 1 plus 5 equals 6, which is just the way that we generated these numbers in Pascal's triangle. We got this 6 by adding the 1 and the 5 together. So Pascal's identity is really just the mathematical way that we generated Pascal's triangle. Okay? They're expressing this in terms of combinations because there is a connection between combination and the rows and the elements in Pascal's triangle, and we're going to look at that in the next lesson. Okay? So let's just look at one more here. We won't do this guy down here. We'll say we've got 100, choose 38. How can we rewrite this in terms of Pascal's triangle? Well, again, we just see a single thing here. So we want to look at this rearranged form here. N choose R is equal to N plus 1, choose R plus 1, minus N, choose R plus 1. So we're going to have two combinations over here that we are subtracting. This expression here on the left-hand side is telling us our value of N and R. N equals 100, R is equal to 38. On the left-hand side, we want N plus 1, choose R plus 1. So 101, choose 39, minus N, 100, choose R plus 1, 39. Okay? So we're just looking at the combinations given, figuring out how this relates back to Pascal's triangle, and putting it in.